Awesome. So this is part D, all about those ideal gases. This is going to be one video to go through all of part 1. So a lot of this is just the content to kind of set us up so that we can do those ideal gas problems. So let's jump in. So for number 1, it says, what is the ideal gas equation? The correct answer is PV equals nRT. Another good way to remember this is Pervner. It's very silly. There's no E. There's a lot of letters that you kind of add, but Pervner is correct. Question 2 says, what does each variable stand for? So we're going to go ahead and write it out. That first one, P, is for pressure. That V is for volume. The N is for the number of moles. The R is the gas constant. We'll talk about that in a second. And the T is the temperature. So the big thing that makes this different than the combined gas law is this part right here. That N variable is adding a specific quantity. So before in our combined gas law, it didn't tell you how much of the gas there was. But for this law, the ideal gas law, it's telling you there's a specific set amount. So now the way to identify and differentiate between combined gas law and the ideal gas law is to see if there is a quantity that's listed. Question 3 says, what are the units for each of these variables? So the most important units you need to know are with this gas constant. If you know the units for your gas constant, you know what the units for all of those other parts should be. So our gas constant, or R, is 0.0821 liters per atm per Kelvin mole. So that has 4 different units because this whole thing is going to end up canceling our units. So if you checked out any of those combined gas law videos, you should have seen that we followed through with all those units. Our gas constant, all of those units are going to be canceling all of our other units as we go through these problems. So just based on this one variable, we're able to figure out all of the other, blanking on the word. All of the other units. There we go. Sorry. So for temperature, we see the K, so it is in K or Kelvin. For moles, pretty self-explanatory. It's going to be in moles, so you're never ever going to use grams, liters, meters, whatever. It's always going to be moles. Volume will be in liters. P for pressure will be in atm or atmospheres. So keep in mind you'll have to convert everything to atmospheres, everything to liters, and everything to Kelvin for every single problem that you plug into the ideal gas law. The next one, what is the value for R including units? There it is. We've already gotten it. This will be given to you for your tests, quizzes, all that kind of stuff. But the important thing is make sure you have it. You got to know it. If you know those units, you're good to go. And our last one, what does STP stand for? So this is super important. So STP stands for standard temperature and pressure. So anytime you see those 3 letters, STP, you are being given 2 different parts of this equation, the temperature and the pressure. So the temperature is always going to be the exact same. It's going to be 0 degrees Celsius, but again, we know we never plug in Celsius. It's always going to be Kelvin, which will be 273.15 Kelvin. For our pressure, there's a ton of different units you can use, but if we're ever using our ideal gas law, which is what this whole unit is about, we want our pressure unit to be atm. So the STP pressure is going to be 1 atm. Awesome. So that's our introduction. The last part is, it says question 6, what are the conditions for STP, 273.15 Kelvin and 1 atm?